is motion, there is wear. Introducing the MW Model 10 powder spray torch. Maintenance Welding Alloys has been perfecting the concept of flame spraying for over 25 years. They are recognized by the welding industry as manufacturer of the finest powder spray torches available. In the flame spray process, the thumb action feeds the finely powdered alloy metals through a specially designed oxygen acetylene welding torch. These very fine metal particles are superheated as they travel through the flame, which sprays and welds them to the workpiece. It's like spraying from an aerosol can. Remarkably simple and easy to use. Now let's take a closer look at the torch in action. One of the outstanding features of flame spraying, a sweep, is the slick, glassy, smooth surface it automatically produces. This means less horsepower to pull implements through the soil. Look how the deposit flows right out to the cutting edge so that the softer, unsurfaced side of the tool wears first, causing a self-sharpening effect. 3 years of field tests show that no matter how abrasive the different soils may be, the life of a flame-sprayed tool is consistently greater than an unsurfaced one, double at least, and often 3 or 4 times greater. New hard-faced tools sold by manufacturers have a rough textured surface. This is better than nothing, but they do not provide the value for the hard-faced dollar the farmer can get by flame spraying them himself. Hard-facing this sweep takes less than 10 minutes and costs about $2.50 for the gases and powder. A plain or unsurfaced sweep, which sells for $7.50, costs about $15 if it has been pre-surfaced by the manufacturer. On a cultivator, using 30 or more sweeps, the potential of saving $5 each translates into about $150 gross savings, thanks to 5 or 6 hours' time with the MW powder torch. You can see that flame spraying, which may be easily and conveniently accomplished by the farmer himself, not only increases tool life, it saves cash outlay. At the same time, the glossy, smooth surface improves tool efficiency. Other tillage tools, such as bean knives, chisel points, drill shoes, and furrowers, lend themselves perfectly to this push-button, hard-face process. Let's look at some different hard-facing applications. At $75 a piece, Packer wheels are expensive. This wheel is to be repaired and hard-faced at the same time. As you know, what metal is left is paper thin, but the MW torch lets you apply coats as little as 2 or 3 thousandths at a time. Metal as thin as a coffee can may be flame sprayed without burning through. See how quickly the process moves. A packer wheel takes about 15 minutes to hard surface. The deposit here is about 1/32 of an inch thick. This job was done earlier this year at the Gale Raddatz farm a few miles west of Lorenzo, Nebraska. Mr. Raddatz salvaged a total of 35 wheels, some John Deere and some Noble, and found that by flame spraying them himself, his cash outlay was under $7 per wheel, and that included oxygen, acetylene, and powder. The MW powder torch, combined with its special powders, makes every farmer an expert at maintaining his own equipment. Since harvest time is the bottom line, take a good look at what's going on here. The efficiency of the platform auger in delivering the straw to the cylinder begins to fade when the leading edge of the flight starts to round off. While welding washers, or whatever, to the flight is better than nothing, for better performance, we would heart base the flight with MW number 61 powder. Apply a thin deposit, about 1/32 of an inch thick at the leading edge, and let the deposit feather out to nothing over a distance of 1/2 inch or so. Farmers who have hard-faced their equipment tell us that for the best operation, we should grind the overlaid flight edge square, like an ice skate, so the flight will grab the straw and deliver it evenly to the cylinder. On a 20-foot machine, the whole job, including grinding, takes about 6 hours and about $50 worth of powder. It's important to remember the MW torch is definitely user-friendly. Because of its unique design, plus use of specialized companion powders, the user need not be experienced in welding technique to attain immediate and profitable results. Let's talk about cast iron for a moment. No repair procedure has ever meant so much to so many. A machine will often continue to operate, even though it has long since worn out. But when a casting lets go, production stops now. This rosebud preheating tip also sprays powder and is included with the MW torch package. Building up a missing or worn gear tooth, as we see here, is a simple operation with the MW powder torch. It is designed to permit control of the deposit within about 5/1000th of an inch of the desired finish dimension. The MW21 cast iron powder used here files readily and can be touched up to finished dimensions. Cast iron is generally difficult to weld, but under the MW torch, it's a piece of cake. There are nonetheless still some castings that are impossible to weld. However, with the MW torch and MW21 cast iron powder, about 99% can successfully be repaired. Take this manifold on an antique tractor, for instance. It wouldn't cost too much if you could find a replacement. In this case, the owner didn't have a choice. It was fix it or forget it. Here again, with the MW torch, repair was made quickly and economically. This intake manifold off a 1950 tractor was broken trying to remove it from the tractor. It's all cleaned up and ready to weld. All you have to do is preheat and fill the crack all the way around. You can position the tip so that you may tack all corners in order to preserve alignment of the two pieces. About 2 years ago, this 8-inch gate valve on the Ron Gillum farm, southwest of Sterling, Colorado, froze and cracked open.
Broke out and cracked it in the top.
It was repaired while in place with the MW torch and $4 or $5 worth of MW21 cast iron powder. Being able to repair without disassembling the unit was a big advantage. The complete job took less than 1 hour.
Of work involved in the fixing of the valve.
This how-to section will illustrate the basic torch procedures and acquaint you with the special powdered metal alloys which have been developed for general maintenance work and specialized hard-facing applications. Let me emphasize that the flame spraying process is not a substitute for conventional torch and arc welding. Rather, it is a recently perfected and entirely new type of welding procedure which is opening additional opportunities for substantial savings in day-to-day maintenance and repair work. The purpose of this film is to enable you to pick up an MW Model 10 powder torch and promptly reap the benefits of this new process. Most people think building up this gear tooth would require a lot of experience and practice. Not at all. It's even easier than it looks. The number 21 powder we're using here has an exceptionally wide plastic range so that it holds its shape. When you have a puddle established, it just sits there and lets you add more powder so you can build up the deposit to the shape you want without worrying about it dropping off on your foot. Building up a thick deposit is one thing, but what about paper-thin overlays? Probably nothing illustrates flame spray more dramatically than laying down a 5 to 10 thousandths overlay and have it come out within a couple of thousandths. So stay tuned. Not only are we going to show you how it's done, but how you can do it yourself on your first try. Once you have the feel of the torch and know what to look for in the deposit, you will see what we mean. First, let's get acquainted with how the torch works. In the Model 10, oxygen and acetylene passing through the venturi of the powder injector produce a vacuum. When the powder feed lever is pressed, the vacuum draws the powder from the hopper into the flowing gases, which carry the minute particles into the flame, bringing them to high temperature before they strike the preheated work. These superheated particles penetrate into the work surface like a drop of water into a cube of sugar and produce a true weldment. Unlike the metallizing process, flame spray deposits are welded in and do not peel off. Now let's put the torch together. When assembling the hopper section to the torch butt, just finger tighten. When you install the tip assembly, Line up this keyway with the guide pin you see in the hex body. This aligns the powder feed passages and keeps them aligned so the tip end can be positioned to suit the work. Like this, for instance, for overhead work. When changing the position of the tip, loosen the tip nut about half a turn. It's important to note, as you see here, that both the individual tip ends and the injector are stamped with a number. Since each tip end requires its own matching injector, be sure these numbers match when you replace a worn tip end. Incidentally, these numbers tell you the cubic feet of flow per hour of each gas. When setting the regulators, set the oxygen at 20 pounds and the acetylene at 15. Although the Model 10 accommodates a broad range of tip sizes, that is from 6 to 55 cubic feet per hour, use the same settings for all tip sizes. These settings are important because the gases have to pass through the venturi of the powder injector in order to produce the vacuum which draws the powder. Now let's light up and adjust the flame. To get the ideal flame setting and minimum powder overspray, turn on the acetylene only and adjust the flame so it's just jumping off the tip like this. This automatically gives you the proper amount of acetylene flow for any tip size you happen to be using. Now go ahead and add the oxygen to establish a near neutral flame, like this, which is what you want for flame spraying. When you're spraying powder, the flame cone should look like this. What you should know about the powders. The powders used in flame spraying are basically nickel-chromium alloys, and all of them are wear and corrosion resistant. There are 4 primary types, and they are numbered to show their nominal Rockwell hardness: number 21, 41, 61, and number 88. The powders are packaged in 1, 10, and 30-pound containers. 1 pound of powder will cover about 120 square inches, 1/32 of an inch thick. The number 21 powder is almost pure nickel. As you know, nickel is relatively soft, so the deposits file easily and machine freely. Yet because of its high density and low coefficient of friction, this non-sparking alloy will outwear mild steel several times. This feature makes it a good choice for an overlay where you need a long wear life from a relatively soft and machinable deposit. The most important thing you should know about this alloy is that it was developed specifically for the repair of cast iron, such as this pump housing. Experience considered, it can now be said flame spray welding of castings with number 21 is the best procedure that has ever been developed for consistently successful cast iron repair. Number 21 has also been extensively proven in the glass container industry, where it is used for the repair of cast iron glass molds. Repairs on these expensive molds must be flawless, since the slightest imperfection would show up on the glass surface. This ice cream maker was cast from a special high nickel alloy and was severely gouged on its highly polished inside surface. Replacement cost would have been around $3,500. The repair job took only about 4 hours and less than 2 pounds of powder. It's been back in service for 5 years. When castings are involved, some of the most enthusiastic testimonials come from users who, thanks to flame spraying, have been able to salvage a casting which they previously tried to braze or arc weld, only to have it fail irrespective of their best efforts. The principal feature of the spark-free number 41 is its outstanding corrosion resistance, which makes it an interesting material for marine and chemical applications. 41 is a medium-hard alloy which is also popular for shaft overlays where a harder but machinable surface is required and a sturdy lathe is available for finishing. Many shops make substantial savings by fabricating a part out of mild steel and then cladding it with a 10 to 15 thousandths coat of number 41 to give the part the corrosion resistance of solid stainless. In fact, this technique has been used for years in the oil field for fabricating sucker rods and in the food and chemical industries on augers and hydraulic rams. You can see that in the world of flame spraying, a little imagination and ingenuity applied to the idea of cladding can develop into real money savings. The MW number 61 is very hard. It contains a lot of chromium, which gives the deposit its smooth and slippery surface. It's an ideal choice for tillage tools, since it takes less horsepower to pull a smooth tool through the soil. For the industrial user, it's interesting to know this non-sparking super alloy, while hard at room temperature, is also hard at red heat. Wow! When a file skids like that, you know you're dealing with something hard. Just look at that. All the file does is burnish the work. The last powder is number 88, which is basically number 61 with the addition of carbide particles. Carbides don't, of course, fuse to the work, so the number 61 acts as a matrix to hold them in place. Use it where abrasion conditions are a real bear cat. There are two basic procedures. The first is fog coating and fusing without adding additional powder. This technique is used for thin overlays ranging from 5 to 10 thousandths of an inch thick. The second procedure is spraying and fusing simultaneously. First, let's look at the fog coating procedure for thin overlays. With the work ground clean, preheat to about 800 degrees. That is when it's just ready to show color. At this point, holding the tip perpendicular to the work and about 1.5 inches away, spray on a fog coat. If you're looking for about a 5 thousandths of an inch finish deposit, apply just enough to fully cover the surface and give it the appearance of fine grit emery paper, so that it looks like this. Okay, let's get back to wetting out so you can see the action under the flame. Hey, how about that? Now that's what you want to see when you talk about flame spraying. Look closely at the wetting action you're seeing here. Notice the slow, deliberate torch motion and how flat and smooth the deposit is wetting out. Note this action carefully because in just a few moments we're going to apply the principles you're now seeing to building up a worn shaft. Here's what we have: the ground surface, the fog coat, and the deposit fused in. What we're shooting for here is about 5 thousandths of an inch finished thickness. Let's check it out under a dial indicator and see what really happened. The fog wants to be around 7 to 9 thousandths of an inch thick in order to get about a 5 thousandths of an inch deposit. Isn't that amazing? Would you believe? A freehand deposit, dead flat and right on the mark. Okay, now that you know what to expect and to look for, let's apply this procedure to a shaft where the action is faster and harder for the camera to pick up. As you're preheating, watch for those heat lines, and when you can see them following the flame like a shadow, it's time to start applying your initial fog coat. In addition to giving you a 5 thousandths of an inch buildup, the initial fog also keeps the shaft from oxidizing while you bring it up to fusing temperature. Now, with the fog coat evenly applied and without adding more powder, wet out this initial coat like you're seeing here. To increase the finished deposit thickness, while the work is still near fusing temperature, simply apply additional fog coats, wetting out each coat as you go. Each coat increases your deposit thickness by about 5/1000ths of an inch. Now, let's talk about the second technique, spraying and fusing in one operation. While we're getting some preheat into the workpiece, let me stress the importance of having the work perfectly clean. Generally, grinding is the best approach. Sandblasting should be avoided. After the preheat, bring the target area to cherry red and apply a small burst of powder which should wet out instantly. Continue adding powder in short bursts to establish a puddle that will have the finish thickness you want. What you're seeing here is about 1/32 of an inch thick overlay. Having established the puddle, direct the flame so that the work is being brought to temperature ahead of the deposit and the puddle is flowing along smoothly and without any holidays. The distance you hold the tip from the work will range from a 1/2 inch to 1.5 inches. As you can see, flame spraying doesn't take very long. In fact, this tillage tool from preheat to finish, which you just saw in real time, took less than 1.5 minutes. So there you have it, a practical procedure that's simple and easy for dealing with wear problems, either as a preventive technique or a method for salvaging parts otherwise headed for the scrap bin. Flame spraying is used extensively in the smokestack industries and by the agricultural user because it provides direct cash savings in farm operating costs. It's used by industrial manufacturers, the automotive industry, oil and gas companies, and maintenance people in all fields who are taking advantage of this remarkable time and money-saving process. The MW Flame Spray package includes the Model 10 powder torch, along with the 2 most commonly used sizes of spray tips, plus the MW Rosebud tip, which may be used for preheating as well as spraying. Also included is 1 pound each of MW number 21 cast iron powder, number 41 shaft overlay powder, number 61 hard face powder, and number 88 carbide particle powder. Operating instructions and parts list are all packaged in a convenient storage chest. The amazing time and money-saving world of flame spraying is waiting for you. To place an order for your torch, contact your MW distributor, or for additional information, call Maintenance Welding Alloys at 714-770-7027 in Laguna Hills, California.